Today, I'd like to implement Semantic Search. I have an application that's basically a database of inspiring quotes, and I'd like to search them by their meaning. So I'm not looking for exact words, but rather a piece of text that has similar meaning to the phrase I type in the query field. The starting point here is a basic Elixir application with Ecto and PostgreSQL configured. We have one schema called quote with content and author fields, plus standard timestamps like inserted at and updated at. What we'd like to do is to add possibility of semantic search here. But how to implement that? First, we need to generate so-called embeddings. Embeddings are vector representations of the meaning of a specific piece of text. By vector, I mean a vector of a large number of floating point values. Once we generate such vectors for each entry in our database, we can find the ones that are closest to the vector generated for our query string. So we basically need two pieces of our puzzle. The first one is vector storage and search. The other is generating embeddings. For the first part, we'll use Postgres extension, pgvector. For generating embeddings, we could use some local model, but today I'll just use OpenAI embeddings and the Rec library with ReqLLM plugin that will make our life easier when querying the OpenAI API. As I said, we have this quote schema in our application, but I also created, or actually generated using an LLM, some test quotes. We can use them to test our application later. Let's start with the vector part. We need to install pgvector for Elixir first. We can add it to our mix.exs file and call mix.deps.get. Now, when we have it installed, we just need to follow the instructions from the official documentation. In our case for Ecto, because we use Ecto in our project. There are a few steps to follow. First, we need to define a specific PostgreSQL type. I'll just copy this line and put it in the Postgres types file. We need to replace my app with our real app name, which in my case is quotes. Next step, we update our config file. And finally, we need to generate a migration that will install the vector extension on the database side. I'll just copy required contents provided in the documentation to this file. And that's it for the configuration. We can now add a new field to our quote schema. Let's call it embedding. Its type would be pgvector ecto vector, but we'll also need another migration to change it in our database. So let's create one. What we're going to do here is alter our quotes table and add a new column called embedding. We have a type of vector and also set the size. The size is dependent on the model we're going to use. In our case, when using text embedding 3 small from OpenAI, the size would be 1536. While we're here, we can also create an index to make vector search faster. We need to specify the algorithm. HNSW is a good default, unless you have some specific conditions like memory limitations or write-heavy app. And we also need to specify the function that will be used to calculate distance between vectors. Cosine distance is often recommended for text embeddings, but if we have normalized embeddings, like in the case of OpenAI API, we can basically use other distance metrics and get the same results, like L2 distance, for example. Now we call mix.ecto-migrate, and our database is ready for storing and searching for embeddings. But we still need to generate those embeddings somehow. For that, we'll use the OpenAI API and the Rec library with ReqLLM to make calling this API easier. Let's add it to our mix.exs file and install it first. Now I'll add a module called embeddings that we'll use to store all embedding related functions. The first function will be used for generating embeddings for a string or multiple strings. It will be basically a wrapper for the ReqLLM function. The first argument here would be a model name. We'll put that in an attribute in a moment. And the second one will be the input itself. That's it for this function. But to make it work, we also need to provide our OpenAI API key. One way to do that is in our .env file with the OpenAI API key variable. Let's see how it works. We call quotes embeddings embed for any text like hello. And we will receive this long vector of floating point values from the API. We can also provide multiple values like this, and we'll receive a list of lists. As I mentioned before, I have this seed file here to generate some quotes for testing purposes. But to make it work with embeddings, we need to create a function that will generate embeddings for all of them. Let's quickly do that in our embeddings module. There's not much related to embeddings generation itself here, so let me just copy and paste it. We're just querying the database for all the quotes that have empty embeddings field. Then we're taking all the content from each of them and providing this list of content values to our embed function. Once everything goes fine, we're calling update quotes, which basically pairs each result with a quote and updates its value. If there are errors, it just logs them. Let's just see how it works now. We can call ReqLLM first to see the quotes before making changes. As you can see, the embeddings are empty for all of them. Now let's call generate missing embeddings. Let's check again. And now each one has this vector values stored in the database. But actually, this long vector doesn't need to be returned in each query. We just need them for searching purposes. So one last thing to do is adding this parameter here that tells Ecto not to load this value when querying the database. Let's check it one last time. And yeah, embeddings are now nil in the query results, but actually they are still there in the database. Coming back to the most interesting part, let's implement the search function itself. I'll add the necessary import first, and the search function takes a query string. What we need to do here is first generate an embedding for this query string, and then compare this embedding to all other embeddings in the database, and get the ones that are closest to it. Generating embeddings, as you've seen before, is now quite easy. I'll use the with syntax here to catch and propagate errors. We call embed on our query, and if everything goes well, we'll perform the search. We start by calling quotes repo all with our query, and we're looking for quotes that we want to order by distance between the embedding of each row and the embedding of our query. This cosine distance function here is provided by our pgvector library. As I mentioned before, we could use something different, like L2 distance, for example. And that's basically it. We'll have all the quotes ordered by their distance to our query. It makes sense to limit the results, for example, to 3 in our case. And one more thing, it is good to make sure that we're not returning results that are totally unrelated to our query. So we can do something very similar to this order by, but now we use our cosine distance in the where clause. Cosine distance can take values between 0 and 2, where 0 means identical results. I found that 0.7 works well in this case, but it's basically trial and error. Let's test it out. I don't know what quotes were generated by LLM, but I can search for something like meaning of life. And we got 2 quotes matching our query. Cool, it works. Let's try something different, like recipe for happiness, for example. And we get another 2 inspiring quotes. The whole point of semantic search, though, is that words used in our query don't need to match words in our results. So, for example, having that first quote about recipe, flavors, and ingredients, we could try searching for something like cooking. And it still returns the very same quote. Perfect. To summarize, we integrated 2 tools. The first one is pgvector, which allows us to store vector type values in our database and search for values based on vector distance. That's very helpful for semantic search in our example. For the other part, we used ReqLLM to connect to an external API that will generate embedding vectors that are later used with pgvector. You can find out more by checking pgvector Elixir docs, as well as pgvector documentation itself. And you can also have a look at different algorithms and distance functions there. And that would be all for today. Thank you, and until the next time.